Math 096 Lecture 30. Today we're going to be talking about the first day of Section 5.4. And to begin this section, we're going to be talking about items called polynomials. So to get us into that definition, as you look at your handout for the day, you'll notice that I've started the handout with a reminder. Anytime you have two different algebraic expressions that are added together, those two pieces are called terms. So we'll use that throughout the day. And then once you have that, we're ready for the definition of a polynomial in one variable. I've given that to you in a box. Go ahead and read that information. Now, as you look at that definition, it says that we're going to have lots of different terms, and they're going to be of the form a times x to the n, where a is going to be a real number and n is going to be a whole number. Now, in this section, the fact that a is going to be a real number doesn't really eliminate anything from the world of polynomials. So we're not going to have to worry about that too much. But this idea of n being a whole number becomes a big issue as we're determining if something is a polynomial or not. So what you have to remember is that a whole number then is all of the integers, 1, 2, 3, 4, and so on, as well as the number 0. So whole numbers are 0, 1, 2, 3, and so on. So as you look at your handout, you're going to notice that I have a statement there that because n has to be a whole number, it can't be negative, it can't be a fraction, and it can't be in decimal. So you want to keep that in mind then as you look at some of the first problems in this section that ask you whether you're looking at a polynomial or not. So let's go ahead and check out the table that I've given to you. So in this table, we're going to look at a whole bunch of different things associated with polynomials. So let's go ahead and fill in the first column. I'm going to give you the expression 10x on that top of that first column. So go ahead and write that up there. And then the first question is this a polynomial? Now, in order to answer whether this is a polynomial or not, what they're asking us to do is to look at this term and ask two questions. Is the a value, the number in front of the x, a real number? Well, 10 is a real number, everything's fine there. And then the second question that's being asked is the exponent on this x a whole number? Well, the exponent currently is not written. So let's start by writing that exponent. Anytime you have an x that doesn't have a written power, we know that that power is 1. And 1 is definitely a whole number. So because the a value is real and the n value is a whole number, yes, we're looking at a polynomial. So I'll just write down the word yes there. Now the next question then is, does this polynomial have a special name? Well, if you look at the word polynomial, it's simply saying that you can have lots of different terms. However, if you have a very special number of terms, then you can replace this word poly with something that specifies exactly how many terms you have. So remember that terms are connected to other things by addition. So in this case, it's not connected to anybody by addition, so that means we have one term. And because we have one term, this can be called a monomial. And what's happening is we've just replaced that poly with a mono to specify the fact that we have one term. So a monomial is the special name of this polynomial. The next question then is this polynomial written in descending order? Descending order is asking, as you look at all the different terms that are running around here, do we have the highest power of x first, and then does that go downhill as we go to the right? In this case, we only have one term, so the answer is yes, it is in descending order. Next off then, we have to figure out the degree of our terms. You'll notice that I've given you subtables for this one. So I have a table here on the board, I'm just putting abbreviations T and D, T for the term. Well, our term is 10x there. And then we've seen over on the left-hand side that there's actually a definition over here. The degree of a term is going to be talking about the power of the variable. Well, as you look at this once again, 10x, the power on that x is 1. So the degree of that term is 1. Now in this case, once again, we only have one term, so I don't have anything else in this table to look at. And the final piece, the degree of the polynomial. Once again, over on the left-hand side, I've given you a definition. The degree of the polynomial is the highest degree that you can see in this previous table. Well, the only degree that I see in that previous table is 1. So the degree of this polynomial is 1. So now that we have that then, let's go ahead and check out a more interesting polynomial. So we have 9w to the 4th minus 5. Now this time, in order to answer if this is a polynomial or not, I have to look at each term individually. 9w to the 4th is one of my terms. And again, I have to make sure that 9 is a real number and 4 is a whole number. The answer on both those is yes. And then as you look at the negative 5, everything's fine there as well. Our negative 5 is a real number, so this is a perfectly acceptable polynomial. So yes, it's a polynomial. Does it have a special name? Well, again, it has 2 terms. So we want to make a comment about the fact that this isn't a polynomial. It's a special polynomial that has exactly 2 terms. So anytime you have a polynomial with 2 terms, it's going to be a binomial. Is this polynomial written in descending order? Highest power w in the first spot, and then we go downhill from there? Sure. So yes, it's in descending order. Now, because we have 2 terms, I need to, in the next spot, write down then both of those terms individually. So 9w to the 4th is my first term. My second term, the second piece that is being added to that then, is a negative 5. And notice I'm bringing the sign with me. So now, as I look at these 2 pieces, once again, the degree is the power on the variable. So 9w to the 4th, the power on that variable is 4, so the degree of that term is 4. And then, as you look at the number negative 5, sometimes people look at that and they struggle a little bit about how to write down the degree on something like that. So, as you look at this, I'm going to give you 2 different ways of thinking about it. First off, I'm simply going to have the everyday knowledge. As you look at this negative 5, does it have any w's next door to it? The answer is no. And because we don't have any w's, another way of saying that is we have a missing w. That means we have 0 of those w guys. So we would have a 0 sitting there. But officially, what's really happening here is that if you look at that negative 5, we can really think about that as negative 5 times 1. Because negative 5 times 1 is still just negative 5. But if you think about our exponent rules from the other day, we have this idea about a 0 exponent. The 0 exponent says that 1 is really the same as w to the 0 power. So when I look at this 9w to the 4th minus 5, that negative 5 is really negative 5w to the 0 power. And once I realize that that's equivalent, once again, I can see then that the power of my w, the power of the variable, is going to be 0. So that's just another way of thinking about it, and that's the more precise mathematical way of thinking about it, that our degree is going to be 0. And then, finally, the degree of the polynomial, once again, is the highest degree that we see in this table anywhere. Well, the highest degree that I see there is 4. So the degree of that polynomial is going to be 4. Well, let's check out another polynomial. We're going to have 7 minus 3x plus x squared. Now, once again, I have to look at each of these 3 terms and ask those same questions. So 7, yes, that's a real number, everything's fine there. Negative 3x. Negative 3 is real, and the power of 1, again, I can write that, is a whole number. So n is a whole number, everything's good there. And then finally over here, we have a real number as our coefficient of 1, and we have a whole number for our exponent of 2. So everything is going fine on every single one of those terms. So yes, that is a polynomial. Now the next question is, does this polynomial have a special name? Yes. We have 3 terms this time. And because we have 3 different terms, we want to think about how to change this to say 3 of something. So this one is a trinomial. Now, as you look at these special names, one special thing to notice on this one is that, in fact, these are the only 3 special names: monomial, binomial, and trinomial. Once you get to a 4-termed polynomial or a 5-termed polynomial or a 7-termed polynomial, you simply go to the general word of polynomial. So once again, we only have special names for 1, 2, and 3-termed polynomials. Next off then, the question is this particular polynomial written in descending order? So once again, the question is, do we have the highest power of x in our first term? The answer is no on this one. So I'm going to start off by writing no. And then the question is, well, okay, if it's not written in descending order, how could we rewrite this so that it is in descending order? Well, as I look at all of these different terms, the highest power of x in this problem is 2. So I'm going to go ahead and put x squared first. And then my next highest power would be x to the first. So let's put that next, minus 3x to the first. And then finally, we're going to have our constant term of positive 7. So if I have something that's not written in descending order, I can move the terms around and I will be able to write it as a polynomial in descending order. So this is an equivalent version of that polynomial, x squared minus 3x plus 7, and that's in descending order. So now that I have that then, I can go ahead and talk about the degree of those 3 terms. So I'm going to go ahead and choose to write down my terms in the order that they are in descending order there. So I have an x squared, I have a negative 3x, and I have that positive 7. The degree, once again, for a polynomial in one variable is simply the power on the x. So the power on the x here is 2, the power on the x here is 1, and the power on the x there is 0. Once again, we could play that game of rewriting it as x to the 0 power if we wanted to. So degree of a constant is always going to be 0. The degree of the polynomial, then, is the highest of all of those degrees. So the highest number that I see in that list is 2. So the degree of this polynomial is 2. Next off, let's go ahead and check out an expression 2/3 z to the 9th. So once again, as I look at this and determine whether this is a polynomial or not, I have to ask 2 separate questions. Is the coefficient, the number out in front, a real number? 2/3 is a perfectly acceptable real number. Fractions are real numbers. So everything's fine with the 2/3. And then the 9, that exponent, is a whole number. So everything's fine with the a value and everything's fine with the n value. So yes, this is a polynomial. Now, at this point, this is once again one of those one-termed polynomials. So yes, it has a special name. It's a monomial again. And because it's a monomial, we only have one term, so yes, it's in descending order. One term was 2/3 z to the 9th. The degree of this is going to be 9, and once we realize there's only one term, that means then that the degree of our polynomial is going to be the highest degree here. There's only one of them, so it's going to once again be 9. Now, as we look at our last example, I'm going to write down 5p to the negative 3rd power. So 5p to the negative 3rd power, 5 is a perfectly acceptable real number, but negative 3, our exponent, is not a whole number. Remember once again that whole numbers can't be negative. And because I'm trying to have a power there that's negative, I'm not looking at a polynomial. So the answer here is no. And once I have no as the answer for this on, no, this is not a polynomial, I can't answer any of these other pieces, because all the other pieces then are all associated with only polynomials. So this is one example where we would have to exclude it. Remember once again that the other things that would exclude something from being a polynomial is if the power was fractional, like 7/3, or if it was decimal, like 0.9. All of those things are things that cannot be in the exponent.